All right, pre-algebra. We're going to be looking at solutions of linear and nonlinear equations really quickly here. And I'm going to be honest with you, this is a very simple lesson when it comes to what we've been doing as far as graphing, and it kind of just ties everything together to make sure that you can check to see if we have a solution or not. And so let me just read through what's happening here. And you don't have to take any notes with this first part, but I will want you to write down a couple of things as we continue on. So here's what it says: building understanding. Not all equations with two variables represent linear equations. Okay. If you look over here, we have some examples. And actually, if you take one of my calculators, and I wanted to show you this, but I couldn't find my calculator emulator to show you it. But if you take one of my calculators from the back of the room, and you press on the y equals, and you're able to enter any of these equations in there, and then press graph, you're going to see lines that aren't lines. It's going to be, some of them will be like, we call them ellipses or hyperboles, and so a hyperbola. You can check that out, play with it. I always like playing around with it because I sometimes forget what the shapes are going to look like. But anyways, a nonlinear function is represented by an equation whose graph is not a straight line. It makes sense, right? If it's nonlinear, it's not going to be a straight line. It's going to be a curved line. Is it still called a line if it's curved? Yeah. The solution of the equation are values that make the equation true. Okay, so they're values that are actually within the equation. When the equation has two variables, there are usually an infinite number of solutions. Because if you plug in one variable here, okay, a number, another one comes out there. Plug in a number here, a different one comes out there. And so there's an infinite number of solutions. For many numbers there's that many solutions. One way to determine the solution of a nonlinear equation is to substitute an ordered pair into the equation and check whether it makes the equation true, if equality is still maintained. And I'll show you that in a second. Another method is to check the solution is to determine if the ordered pair is on the graph of the function. And we'll see that in a second as well. Okay, so looking at this first one, example 1, I'd like you to write this out. Determine if the ordered pair is a solution. And write this down right here. Now, if you need to take a couple seconds to pause the computer so you can get that written down and then listen, you might want to do that. In fact, you can go ahead and do this one as well, and even graph out this one with the 2 right there. Okay, so take a moment, pause your computer, and we'll be right back. Okay. All right, I hope you had a moment to go ahead and jot that down. If not, like I said, you want to get that down. But if we take a look at this first one, what we're going to do is we're going to substitute in the -4 and the -1 for the x and the y. So I'm going to go ahead and do this. I'm going to substitute that there. The -4 for the x. And we're going to see if equality is maintained, if both sides are equal. So if I go ahead and plug this in, -1, half of -4 would be -2 minus 3. Okay? Now, if I take half of, or I'm sorry, not half, we're done with the half. If I take -2 and subtract 3, you get -5. So the question I have for you guys is this: is -1 equal to -5? And the answer is no. So what we know by doing this whole process here is that this point is not on that line right there. Okay? If I do the next one, oh boy, we got those crazy looking brackets. Do we remember what those are called? Hopefully you do. Absolute value. Okay, and what does the absolute value mean? Well, it's the distance from 0. Now, can you ever have a negative distance? No. So if I'm at -10, that's the same distance from 0 as 10 is. How far is -10 from 0? It's 10 units. So if I plug this in, again, the x and the y value is 7, the x is 3, we get 7 is equal to, now what's the absolute value of 3? It is just 3, always the positive. 7 equals 7, so this point we now know is on that line right there. Okay, actually it wouldn't be a line, it would be a curve. Okay. From there, if we look at this last one, if I graph this point and it is on this curve somewhere, then I know that this is part of the solution. So if I graph 2, 0, 2, 0, that point right there is a solution to this graph, this function. Okay? Remember, there's an infinite number of solutions. So maybe I should have said this back here. This is a solution to this graph. It's one of the many. Okay? So from there, give me 1 second here. Sorry, I had a visitor at the door. So again, these are solutions if they maintain equality or are on the graph. If they're not on the graph, then they're not solutions. So, all right, taking a look at the next type of problem here. Let me go on down. Okay. State whether the ordered pair is a solution of the inequality that is produced. Okay. On my graph. Now, we haven't done a whole lot of, oh my goodness, I'm going to sneeze. Hopefully you didn't have your earbud in. Oh, that hurt. My throat's sore. All right. So as you look at these pictures here, I hope you can see this tinted area over here. And what that means, if I was to write out this inequality, I know that x, if this is the line, x equals -1 is the equation. But since it's solid and it's to the left of it, x is everything less than or equal to 1. Okay, that would be the inequality that describes this line right here. And so as a result, if I was to plug in 1, -2, 1, -2, that point right there is within the shaded region or even on the line, then I know that this is an answer to this problem. Okay? All right, so if I were to plug in the x value, 1 is less than or equal to 1, then, you know, that's true. Okay? I should have said -1 there. Okay. X is, oh, I put the inequality wrong direction. Sorry about that. We're on the right side. We're greater than. It's everything greater than, not less than. We're everything greater than. So this should have been this way, which is why it didn't make sense to me at first. Okay. So that's the equation of this line, all this shaded area. And if I plug in the x value, that makes sense now, doesn't it? 1 is greater than or equal to -1. Okay. This next one, if I plug in -2, 4, -2, 1, 2, 3, 4, is this one part of the solution? Nope. Okay. And so as a result, we can just go ahead and say that -2, 4 is not part of the solution. For the last one, 1, -3, if I do 1, -3, right there, that is part of the solution. Now, I'll just tell you this, because I want you to know how to graph these inequalities, because you're going to do it next year in Algebra 1. When you go to graph the inequality, you have to determine both the slope and the y-intercept. The y-intercept here is just 1. The slope is, I'll go ahead and say that these 2 points are on the slope, up to 1, 2, 3, 4, 5, 2/5. So my inequality, because it's below, is going to be less than or equal to 2/5 x, the slope of x plus 1. Okay. So if I were to give you that inequality and you were to plug in the x and the y, -3 is less than or equal to 2/5 the x, 1, plus 1. Okay? So if we work this out, 2/5 plus 1, 1 2/5, what we're basically saying is that -3 is less than or equal to 1 2/5, which is a true statement. -3 is less than that. Okay? So again, I'm taking you much deeper with all this stuff here, all of that. That's much more deep than what you need to know. I just need you to know how to go ahead and determine if the point is a solution. Oh goodness, I'm so tired. All right, so with that being said, let's go back and see if there's anything else we need to cover. Okay, I don't think so. So here's what I want you to do. I want you to look on my calendar and make sure that there's you've got your homework there that I want you to do, and try to do that homework, and you'll turn into the sub after you get done. If you don't get it done before break, make sure you have it for me after break, and we'll talk about it then. Have a great night, and I'll talk to you later. Bye.